Alright, it's another great day for math. So in this question here, the two topics that are in play here is about scale drawings, and also, because we have bearings, it's about trigonometry in fact, on bearings. So the concepts must be in place. So for part A, I'll just fast forward a bit, and I will mark out the position of L considering the bearing of 40 degrees and a lighthouse of 110 km away. I will fast forward now. Right, there you go. So we have marked out a distance of 11 centimeters on the scale drawing, and with a bearing of 40 degrees. So lighthouse L is here as such. Now, second boat B leaves B to meet the first boat at C. Where they meet, the second boat has sailed the shortest possible distance. Now, this is a very common term in trigonometry. It is where the two parts are perpendicular to each other, or rather the two lines. So which line am I talking about? It's where B sails this way, and the line starting from B will be perpendicular to the line AL. So I'll do it precisely now using your set square. There you go. So that line where there's the shortest possible distance is created when the two lines B to the point B to the line AL is perpendicular to each other. That is creating the shortest distance possible. So now we want to find the bearing. So from the north line again, we will go clockwise until we point at the line where they meet. So use your protractor and measure it out, and it should be approximately 310 degrees. Right, so we're done. This is the bearing that the boat must sail on.